Yes, so today in this video I'll be explaining the algorithm to code for pre-order traversal. So for that I'm going to take one tree example here. I'm drawing it here now. So let's suppose we have a tree. Okay, so now I'm going to draw one tree here with the root node 1, child node 2, 3, then 4, again 5 and 6. Okay, so this is a small tree. I'm taking example of this tree here. So what do you think, what is the pre-order traversal here? Okay, if we traverse through this tree to calculate a pre-order traversal, what will the pre-order traversal? That will be, so I'll just make a arrow again to explain the same thing. Okay, we'll first draw the arrow against each node like this, and then we'll go one by one. So first node which comes in our path, that is 1. Okay, so 1 is the output. Then again we go from here to here, that is 2. Then from 2 we are traversing again. Which node is coming first? That is 4. Okay, so 4 is in the output. Now after 4, what comes next? That is 5, right? So I have written 5 here. So after 5, when I'm going through this tree, what is coming next? That is 3. And after 3, it is 6. So this is a pre-order traversal for this tree. Okay, so if I'm now these things I have already explained in the previous video. Now I'm going to explain the algorithm, how we can calculate, how we can program this, what's the algorithm we can use. Okay, so to find the pre-order traversal, we can use stack implementation in our code. Okay, how? Okay, so I'll tell you. So let's suppose we have a container. Okay, container is nothing but the stack here. Okay, so what we will do, we'll have a root node, right? So first what we will do, we will insert a root node here. Yes, so after removing it, what we have to do now, the stack is again empty, right? What we will do, we will add its child node. The child node is nothing but 3. Okay, I'm writing top of this 3 and 2. Okay, so now after this we have placed this 1 inside this result vector list. Now you can see this 1 is not here. Okay, inside the stack. Now what is coming on the top of the stack? Because we know that what is stack, how what exactly stack will do, whichever element is placing on the top of the stack, that will come out first. Okay, previously it was only 1, so we have taken 1 out from the list, but now we can see we have 2 in the stack. So now we will take out 2 from this list first. Okay, and we will place it here in the. So after taking out 2 from here, what we have to do, we have removed it from the stack, and now we'll be adding its right right and the left child, that will be 5 and 4. Okay, so after that, now what comes first? That is 4. So we will remove 4 from the stack. We will write it inside the result list. Okay, now we'll check whether 4 has right or left child. Does it have? No, it doesn't have any right or left child. So we will simply remove it. Okay, we have removed it already. Now what comes next inside the list? What is the top element? That is 5. Same thing we will do. We will place it inside the result list, and now we will check whether does it have any right or left child. No. Okay, we have removed it as well. Now for the 3, now what comes next? The top element, that is 3, right? So we will remove 3 as well from the stack. Okay, we will add it here inside the result list, and now we'll check does it have any right or left child. Yes, it has 6. so we will add it here. Okay, similarly again what we will do, we will remove 6 as well from the list, and now we will add it inside the result list. Now what we can see here, that now at this point of time stack is empty, and now from here whenever we are like in the code, when we are iterating inside the loop, it will stop here when stack is empty. So this is how we can actually find pre-order traversal in the code. So now I'll be proceeding towards, so now I'll be explaining the same thing inside one of the lead code problem for pre-order traversal. Let's move ahead. Yeah. Yes, so this is a lead code problem where we have to find pre-order traversal of any tree, and we have to store it inside the result list in the form of vector. Okay, so now I'll explain you from code. Similarly, like how I have explained in the video, I have explained same thing. We're going to implement it here. What first thing what we will do, the stack. Okay, we'll take one stack of the tree node. Let's name it as st. Okay, it will be this. After that, to store this result, I'm taking one local vector where we will store all the data of stored inside the tree. Okay, then one tree node variable again, which will store the root. Okay, after that I will check the base condition. If what if root is empty, okay, if root is equals to null, then I am returning a empty vector list here. Okay, now what is the first thing which we have to do, what I have explained, that initially I'll be placing the root node inside the stack. Same thing I will do, st.push. Now I will push the root node. Okay, root node is nothing but the node. Okay, I'm pushing the node here. After that, what I have to do, I'll first, because this we have to traverse again and again, right? We have to first add right child, then left child. Same thing we have to do. So obviously we need a while loop or any kind of loop. Okay, so I'm taking this loop. So this loop will be true. Will run until the stack becomes empty. We have also seen in the when I have explained that we are going to basically iterate until the stack becomes empty. So now I'll write this condition until st.empty. Okay, yes, now what we have to do, it's very simple. I have to basically, so now I'm updating node as whatever is the top element of inside the stack. So initially, obviously right now we only have root element, so I'm popping out from the stack. So it is the top element I'm storing inside the node. And now what I have to do, and we have also seen that after popping out that element, we are pushing that element inside the resultant list, right? So what same thing I'll be doing here, st.pop. Okay, that element has left the stack. Now I'll be adding inside the result list, and what I will add inside the result list, the data of that node. So that will be node and value. Yes, that's it. Okay, so now after placing the value inside the result list, what we were doing in the when I have explained that we'll first push the right node and then the left node. Okay, same thing we'll be doing here. We'll be first checking whether right node is there or not. Okay, so if node right is not equals to null, then if it is not equal to null, then what we will do, we will simply push inside the stack. So st dot push node right. Same thing we also have to do for the left node as well. If it is not equals to null, then st dot push left node. And again the same thing will iterate. Okay, and after this what we have to do, so yeah, this is how we basically, you know, will basically insert elements, and then we will whatever be in the top of that stack, we will take it out from the stack and we will store it inside the list. So now after that, simple, we just have to return the result vector list. That's it. So now I'm going to run this. Anything, any issue in the code? No, right? So I'll run this. Yeah, see here, so all three cases are working fine. We'll submit this code. Yes, it's working fine. So this is it. So this is how you can code for the pre-order traversal. I have also explained the algorithm and the coding part as well. I hope you understood the concept. Thank you so much. So now I'll be proceeding towards